So let's take a look at practice test 3. And notice that this one, I didn't cram all into one page. This one I spread out so that you would get a feeling for what the real test is like. I also just did that here. So here we go. Here we go. Find the domain. Now, when you sit down on Monday to take this test, you are going to use whatever strategy works for you. But one thing you might think about is, what are the rules for domain? What are the things I have to be on the lookout for? Give me one.
The first one you have to have is radical.
Okay, if there's a radical in the problem, whatever is under the radical has to be greater than or equal to 0, right?
Right.
So the first thing you might do is just look down through the problems. Do any of them have radicals? Yes, the first one does. So x minus 4 is greater than or equal to 0, so x has to be greater than or equal to 4, right? And you put that in the answer blank. Now, do any of the rest of them have radicals? Yes, C has a radical. So x plus 5 has to be bigger than or equal to 0, so x is bigger than or equal to negative 5. That takes care of that rule. What's the other radical rule?
If it's under the denominator equals 0.
The denominator cannot equal 0. So then you might look at your list of problems and say, okay, A has a denominator. So x minus 6 cannot be 0, so x cannot be 6. So both of these are in the answer blank for problem A. D has a denominator. So x plus 7 cannot be 0 and x cannot be negative 7. Right? So I got answers for I've taken care of both issues. These are the two things I need to worry about. I've taken care of all of them. Notice that I didn't have anything for B because it doesn't have a radical and it doesn't have a denominator. So therefore, its domain is all real numbers. Guys, let's not miss that section. Let's get perfect on that section, right?
Got it.
Okay. All right. Now, section 2. This is where things get a tad bit harder. There's just more to keep track of. We want to find the horizontal, vertical, and holes. So we have A, and B, and C. All right. So I'm going to go ahead and factor the bottom. Generally speaking, in math, not always, but generally speaking, if things factor, go ahead and factor them. It isn't going to hurt anything. And why would I maybe want to factor in a problem like this? In case it cancels. That's right. Now, nothing does, so it didn't hurt me to factor, but there just aren't going to be any holes. So I've got vertical asymptotes, horizontal asymptotes, and holes, and there aren't any. So I write the word none in the answer blank. If there aren't any, write none. Do we have any asymptotes in this problem, though? Yes, we have 2 vertical asymptotes. Where do vertical asymptotes come from? The denominator. And so I have vertical asymptotes at 4 and at negative 1.
Yeah.
Right?
Yes.
How about horizontal? This is a tricky one. The power, look at the original problem. The top has just x to the first, and the bottom has x squared. right? And if the power on the bottom is bigger, then the asymptote is at y equals 0. I'll say it one more time. These have got to be equations. Don't write plain numbers or you're going to miss half credit, assuming the numbers are correct.
What if x squared was on top? Would that be 1?
That's none.
Oh.
That's none. If the big power's on top, there aren't any asymptotes. Oh, yeah, if the big power's on top. All right, I'm going to go ahead and factor this guy. This is b. He factors all over the place. How does the top factor?
X plus 2.
X plus 2, x plus 3, right? Watch it, be careful. And the bottom is x minus 5 plus 3. For those of you that missed the conversation, this is a football jersey that was worn by Mr. McGlynn, and the game jersey in the late 60s.
That's a football jersey?
That's a football jersey,
They were long sleeved.
apparently.
What?
Isn't it amazing?
Good looking.
From the 1960s.
Wow.
Actual game jersey. I was all ripped
They
up by
were
the sun.
pads with it.
Huh?
There were like pads with it?
Not in the 60s.
Yeah.
Yeah, they did. Not like.
I'm sure
Not,
they
they
had
were,
pads.
they were like
Not
leather
that
blades,
long.
that's just about it.
Not on mine.
I don't know. I'm not a football expert. All right, what do we notice now? We got it factored.
It cancels.
We can cancel. So the problem that we are actually dealing with is this now. This is what we're actually dealing with. But because we did the canceling, we know we're going to have a hole. And the hole is an x and a y. And the x always comes from the factor that you canceled out. So if you canceled out x plus 3, your hole is going to be at -3 comma something. The something is not 0. I mean, I suppose it could be, but you can't just automatically put 0. The something comes from taking the -3 and putting it back in here. Right here. Look where I'm pointing. That's where you put it in. So if you put in -3, -3 plus 2, -3 minus 5, I got 1/8. It's possible, it's never happened to us, but it's possible you could have two holes, have two things canceled out, and you would do the same thing for both of them. All right, look at the box. Is there a denominator? Yep. So there's going to be a vertical asymptote. Vertical asymptotes come from the denominators. So in this case, since the denominator is x minus 5, my vertical asymptote will be x equals 5. Notice I have 1x over 1x. So my horizontal asymptote this time is y equals 1. Right? C, I'm going to go ahead and factor x minus 4, x plus 4, x minus 1, x plus 1. Oh, here. All right, so I went ahead and factored, but this time it wasn't necessary because nothing canceled, but it's still good to know. It's going to help me with my vertical asymptotes because I can see that I have two of them, 1 and -1, right? How about a horizontal asymptote this time? 1. Y equals 1. Now, it's a little hard to tell in the factored form, but if you look at the original problem, don't you see x squared over x squared? So that's y equals 1. Okay, so that section we're good. All right, so then we got the sketching section. So the very first sketch is a piecewise function. Now, this test is short. So I expect you to take your time and do careful graphs. Not that they have to be absolutely perfect, but you gotta try to get stuff plotted in the right spot and label some stuff, okay? So here we go. We're gonna sketch this thing. You know how I'm going to start. I'm going to start by putting my dividing line in at -2. That's my dividing line. That's where all the action happens, where all the dots are. All right, x squared. What shape is the top graph, x squared? That's your parabola, starting at the origin. So I'm going to go ahead and sketch my parabola. Okay, notice that it crosses the dividing line right there. That dot will be filled in. And I want the part of the graph that's bigger than to the right, so I need to get rid of this part. Okay, what's that? That's the identity, but dropped down 1. So instead of being that line through the origin, it's now going to be the line through down here. So there it is. There's the line, the identity line dropped down 1. It intersects my dividing line right there. That's an open dot, right? And notice the arrow is pointing that way. So I keep this part and erase all of this part. And then I'll go ahead and erase my dividing line. Make sure you have a pencil with an eraser. Or bring an eraser, you know. And there it is. Got it? What's the test look like? This. Make sure you know how to do this. All right, V. All right, these are a little bit easier. What shape?
Parabola.
Parabola. The difference is it's not vertex at the origin. It's been shifted right 1 and up 2. So right 1, up 2, label that point, 1, 2, and draw in your parabola. Half credit for the right shape, half credit for the right position. Okay? What's next? Yep, C would be next. That's right.
Value.
C is an absolute value problem, which means it is a V, but not Ving from the origin. It is shifted
-1.
left 1 and up 1. So label the point, -1, 1, left 1, up 1, and draw your V.
Will the V always go up? Will it always go down?
The V will always go up unless we put a negative in front. That's in the next chapter. We'll be doing additional transformations. Right now we're just moving the shape. All right, D. Now D is one of these that is a little bit trickier shape. And I am going to pay attention to how you graph it. So you be careful. My suggestion is if it's one of these trickier shapes, go ahead and draw the original picture, which has an asymptote here, you know your exponential, and goes through the point 0, 1. This is your original curve. Agreed? And I would go ahead and draw that. Now we're going to take that picture and we're going to lift it up 1 I know, up 2. Going up 2, right?
Yeah.
So that means everything goes up 2. So this dashed line is all going all the way up to 2. And that point is going up to 0, 3. And there is the picture. The blue one is the answer. So I need to see that that's drawn at 2 and that point is 0, 3.
Do we have to have the asymptotes?
You don't have to have you have to have the asymptote in there. You don't have to have the original picture. I did that myself. You don't need that, but you need to have that blue asymptote drawn and you need to have the point 0, 3 labeled. E is another tricky one. E is a cosine drop down 2. So I'm going to go ahead and draw my regular cosine that goes up and down between -1 and 1. It's a cosine, so it actually starts up here, right? So here's my cosine. That's my regular, normal cosine. Now I am going to pick it up and drop it down 2. So this line, it's not an asymptote, but it's the line that goes, it oscillates across, is actually going to be down here now. And the top of the hill is going to be here. Can you see what I'm doing, guys? I took the picture, and instead of having it oscillate up here at 0, I dropped it down, and now it's oscillating around -2. The hills still go up 1 and down 1, but it's just happening down below now. James?
So for cosine, you wouldn't need to put a point on there, like label anything?
No. You need to have these labeled, the axes labeled, but there's no actual point, no. Oh my gosh. Did I get wild and wacky with this next problem? Oh my gosh, this is craziness. That part's easy. You know what that looks like. What is that?
Square root.
That's a square root function that goes, that's been shifted 2 units to the right.
Yeah.
So this would be easy. Everybody agree? This is so not fair. What, you did it last year, but we haven't talked about it. What does that do?
It makes it go down.
It flips it upside
Yeah.
down. So instead of having the top half, we have the bottom half. And why does Mrs. Ford think that it's okay to put that on there? Well, do you remember when we talked about the implicit functions? And we took the square root of both sides? One side was positive, or one of the equations is positive and the other one's negative. And what difference did that make? One was the top half of the picture and the other was the bottom half. So we're just graphing one of our implicit functions, the bottom half. Magnus is frowning, he still doesn't think that's cool. Okay. All right. Part 4, this is the function part. So here we go. We're evaluating different functions. P of x times q of x. P of x times 2. Emma, what is going on back there this morning?
No, it's not me, I promise.
Are you sure?
Definitely.
You can't talk?
Like I can.
Okay, well, don't. That would be perfect. We'll just be quiet and pay attention. So P of X is 2x squared, and Q of X is negative 3x plus 1. So you're just gonna multiply, kids. This is a distribute problem. So negative 6x cubed plus 2x squared. Done. You're multiplying. Did I do it right? We're okay with that? That's easy. What does this mean? Q of P of X. So we take Px, whatever P of X is, which is 2x squared, and we plug it into Q. So we take the P function and plug it into Q. So Q says negative 3 times x plus 1. So negative 6x squared plus 1. C, P of 2 plus Q of negative 1. All right, so what's P of 2?
8.
P of 2 would be 2 times 2 to the second. Do this first.
4.
So that's 2 times 4, that's 8. What is Q of negative 1?
4.
Negative 3 times negative 1 plus 1, 4. What am I doing with them? Adding them, so
12.
the answer is
12.
12. Everybody good with that? We could have subtracted them or multiplied them or whatever. We're adding them in this case, so we just added them. And then P of Q of 0. So what do we do first?
Plug in
Q of
here.
0. Q of 0 is 1.
Yep.
And then the 1 goes into P. So that is 2
2.
times 1 squared, which is 2 times 1, which is 2. PEMDAS, do the exponent first. 5. Find the implicit function. Functions, I should say. Notice 2 answer blanks, 2 separate equations. And you know they're going to be exactly the same, because one of them's going to be positive and one of them's going to be negative, right? So what do?
Y by itself.
Okay, now you can do this however you want. I'm going to flip-flop these two. So I'm going to have x squared minus 25 equals y squared. So I move the y over here, move the 25 over here. So now I have y by itself. Now what do? Square root. So y equals the square root of x squared minus 25, or the negative square root of x squared minus 25. Do not try to simplify. That does not simplify.
Wait, this is our answers?
That is the answer. Whatever else you do is going to be wrong. Okay? And here, I don't think I showed this class why, so let me show you why. Would everybody agree that 3 squared plus 4 squared is 5 squared? Is that a true statement?
Yes.
Yeah. If you square root both sides and simplify, you would say 3 plus 4 equals 5. Is that a true statement?
Yes.
3 plus 4 is 5?
Oh, no.
No, it doesn't work. If there is a plus or a minus under the radical, you can't simplify. Don't do it. It's going to be wrong every time. Now, this is our 3rd practice test. The other ones, this is where it stopped. So now this crazy teacher is putting on a 6th thing. This is a bonus. This is going to be a bonus question on the test. And I'm even practicing it with you right now because I want you to pass. So here we go. M of n of x is 3x minus 7. So in other words, remember, I erased it, but remember when we found p of q of x and we got our answer, right? Now I'm asking you to start with that and tell me what the two original functions were that made that happen. So does anybody have an idea? We haven't done this before. Anybody have an idea?
Well, we have to look back.
We have to work backwards. All right, I want you to think about this for a second. I need to find an m and an n, of an m and an n function. Let's say, okay, here's your function. Just look at this for a minute. If I picked a number like 10, and I put it in here, what would be the first thing that I would have to do to that number? If I said plug in 10, the first thing that you would do is multiply by 3. So the first function in the composition has to multiply by 3. So the n function, because that's the one that would come first, the n function is 3x. It multiplies by 3. It takes a number and times it by 3. Now, after I've multiplied by 3, then I have to take that answer and subtract 7. So the second function is x minus 7. Now before you get all confused and say, whoa, stop. If these are the two functions, let's build this composition. This composition would say, take n, which is 3x, and plug it into m. What happens if I take 3x and plug it into this function? What does it say? 3x minus 7, which is exactly what I want it to say. All right, we'll do one more. We'll do one more. Let's say a of b of x is x squared minus, no, say x plus 3 squared. And your job is to break that down into an a and a b. Right, so you just stop a minute, take a deep breath, and say, okay, what has to happen first? If I plugged a number like 10 into this, what would have to be the first thing? What would you do? If I said let's put 10 in, would you square first? No, wouldn't you add 3 first? Don't you add 3 first? So the first function, which would be the b function, has to be add 3. Now, the second function takes that answer, whatever you get. So plug 10 in, we get 10 plus 3, we get 13. Then what do? We square it. So the second function takes the answer and squares it. And those are the two functions.
Why wouldn't it be?
Before you get confused, Emma, what you've got to stop and think is, if I built a composition from these two functions, would I get that? So this says take b of x, which is x plus 3, and plug it into a, which would be x plus 3 squared.
Oh, okay.
It works.
But why wouldn't it be x plus 3 squared?
Because you don't add 3 again. You already added 3.
Oh, okay.
You're taking that answer now, which is a new x,
Oh, okay.
and you're squaring it. All right? I don't want to. How much time do I have here? Let's see, today's day 6. Okay. All right. Well, that's it. Let me hand out your megaphones, and then you guys can head out. So.